Alright guys, here is your snow day lesson. There is going to be a worksheet posted for you guys to work on after you watch this lesson. The topic today is what's called indirect measure. This is something that they use to measure things that aren't as easy to measure. So if you imagine going to California and trying to measure like a redwood tree, there's not going to be somebody that climbs to the top and drops a measuring tape all the way down to the bottom. Instead, they measure things like that indirectly. Measuring mountains, measuring things like that. You can measure all of that indirectly, which is called indirect measurement. It's a method of using proportions to find an unknown length or distance in similar figures. Two common ways to achieve indirect measure are using a mirror on the ground or using shadow lengths and finding the object's height. So we're going to actually go through both of those examples. Had we been in class today, I would have done a mirror demo for you to show you kind of how it works, but since we're not in class, we're just going to kind of work through the problems on the paper. So this first example is a shadow example. It says, at 2 p.m., the flagpole shadow is 12 feet long. Bob, who is 6 feet tall, has a shadow of 5 feet long. Find the height of the flagpole. So I'm going to draw a couple just random pictures here. We have the flagpole, and then we have its shadow on the ground. And then we have Bob. We have his shadow on the ground. What happens here is because of the angle of the sun, we're going to have a triangle that forms here. And because the angles are going to be the same, the triangles are going to be similar. Because this ends up being a right angle, and the angle that the sun is making with the ground is the same. These triangles end up being similar by angle-angle similarity. So then we can fill in the numbers that they gave us from the problem. They told us that the flagpole's shadow, that's the one on the ground, is 12 feet. And they told us Bob is 6 feet tall, and that the shadow is 5 feet long. So you have to get all those numbers in the right spot. We are trying to find the height of the flagpole, which is what I'm going to call X in the picture. And then from here, it should be really easy to just set up the proportion and solve. It's X over 6 equal to 12 over 5. 5x equals 72. Divide by 5, X is equal to 14.4 feet. And just check to make sure that that makes sense. The flagpole, since it has a bigger shadow, should be taller. So your answer should be something that makes sense. Alright, let's try another type of example. Each problem we're going to do is a different type of example. Alright, so this problem is a little bit different. It's a overlapping shadow problem. So you're literally going to have somebody standing inside of the other shadow. So what you have to realize here is the picture is going to get drawn differently. So Jill is standing in the shadow of a building, so that the end of her shadow meets the end of the building's shadow. Jill is 5.5 feet tall. She is 20 feet from the building and 8 feet from the end of the shadows. How tall is the building? So to draw a picture like this, we have the building, and we have its shadow, which is going to be pretty long because it's a tall building. Jill is actually standing here inside of the building shadow so that her shadow lines up with the building shadow. So here's her shadow, and they're lined up on top of each other. Where the triangles come into play is, again, if you draw in the line that represents the sun's angle, is you have an angle that comes from the top of the building all the way down to the tip of the shadows. Then you have triangles going on here. But what happens is they're overlapping triangles. So from what we've learned earlier, we're actually going to have to draw these separately. But I would get all the numbers in the picture first. So it says Jill is 5.5 feet tall. We can plug that in, 5.5 on Jill. She is 20 feet from the building. So from her back to the building is going to be 20 feet. And then it says she's also 8 feet from the end of the shadows. So from her to that tip at the end of the shadow, the tip of the triangle is going to be 8 feet. So we can fill all that in, but then to do this problem properly, we're trying to find how tall is the building. We're trying to find X over here. So to do this then properly, we need to draw out two separate triangles. Small triangle is going to be the triangle Jill makes with her shadow, 5.5 over 8. But then the one you have to be careful with is the one for the building. The building here is this big triangle. Because Jill's interrupting the shadows, to get the shadow for the building, we actually have to add those two numbers together. It's 20 plus 8, which is going to be 28. From here, should be relatively easy to set up the proportion. It's just you got to get that big triangle correct. So you got to make sure you're drawing the picture correctly. X over 5.5 is equal to 28 over 8. We get 8x is equal to 154. Divide by 8. And that tells us the height of the building is 19.25 feet. Alright, we have one more example to try. It's going to be the mirror problems, which are even different. So each problem has kind of a different drawing that you need to do. So this is actually kind of cool. It's a way of using a mirror. So had we done the demo in class, it kind of would have showed you what happens in a problem like this. But I'm just going to kind of talk through with the picture on the top. So imagine you're trying to measure the Eiffel Tower over here. What you can do is you can walk back some distance, you can put the mirror down, and then you, looking into the mirror, walk back until you can find the top of the Eiffel Tower. And then the distances we need to know is we need to know how tall you are, how far you walked back from the mirror, and how far you walked back from the Eiffel Tower. If you can find all those distances, which are really easy to measure, you can then find what you want to know over here. You can find x, the height of the Eiffel Tower. So we're going to walk through that in this example. It says Jerry is using mirrors to measure a rocket ship. He places the mirror 75 feet from the rocket ship. Then he walks back 3 feet until he sees the top of the rocket in the mirror. If he is 7 feet tall, how tall is the rocket? So the setup here has to be different than the other two. Every problem is going to set up differently. The first shadow problem, we just had two separated triangles that face the same way. The overlapping shadows problem, we had a triangle inside of another triangle. This one we have two triangles that face in towards the mirror. So I would start by, let's draw Jerry. Here's Jerry over here, and here's the rocket ship over here. Ignore my horrible drawings. So there's the rocket ship. The mirror is in the middle, and the way the triangles are going to be drawn is you have Jerry looking in the mirror, and then the way mirrors work is it reflects out, and so we end up with the same angle he's looking in is the same angle it's bouncing out of the mirror, and then we have right angles here. And now we can put in the numbers that we have. It says that he places the mirror 75 feet from the rocket ship, so the 75 is going to go here. He walks back 3 feet. It's going to go here. And then we know that he is 7 feet tall. So to set this up, we're trying to find that other piece that's missing, which is the height of the rocket ship. And then we just set up the proportion. It's going to be x over 7 equals 75 over 3. Get 3x is equal to 525. Divide by 3. X is equal to 175 feet. So I hope that helps. If you want to, you can go ahead and take a picture of each slide and put it in your notes, or you can do the notes yourself, but I would do something probably to get this into your notes. I might even send a blank version or a filled in version of this so you can have it to add to your notes. Alright, try the homework. I'll have answers for you guys on Monday. I also won't be in class on Monday, so you're going to have another lesson to learn, but we'll take Tuesday to kind of regroup. Alright guys, have a wonderful snow day. Get out there, enjoy the snow, and enjoy the rest of your weekend.